Hey everyone, welcome back to YouTube series on data science and machine learning. In today's video, we are diving into two important concepts that can make break your machine learning models: overfitting and underfitting. These terms might sound tricky, but don't worry, by end of this video, you will have a clear understanding of what they are and how they affect your model performance and how to fix them. So let's get started. Overfitting happens when a model becomes too focused on learning the details and noise in training data. Think of it like a student memorize specific question for a test. They do great on exact question but struggle when asked anything different. The model does great on training data but poorly on new and unseen data. Underfitting is the opposite. It happens when a model is too simple and doesn't learn enough from the data. It is like not studying enough for an exam. So you can't answer even the basic question. The model performs poorly both on training data as well as in new data because it did not learn enough from training. The goal is to find balance between overfitting and underfitting. This is known as Goldilocks principle. Just like in the story where she wanted everything is just right. In machine learning, we want our model to be just right. Neither too complex nor too simple. We want it to learn the important pattern in the data without lost in noise or missing important details. Let's now look at some common causes of overfitting. High model complexity. If your model has too many layers or parameter, it can become too flexible learning even the thinnest detail that don't matter. For example, using a very deep neural network on a small data set increase the risk of overfitting. Insufficient training data. When there are not enough data, the model may memorize the few examples it has seen, leading to overfitting. More data helps the model see a bigger picture and learn general patterns. Noise in training data. If training data has irrelevant information or mistakes, the model might accidentally learn the random pattern, making it overfit. Data cleaning helps remove noise so that the model focuses on the important details. On the other hand, underfitting happens when the model is too simple or when there are issues with the data. Here are some common causes. Low model complexity. If your model is too basic, like using a straight line that is linear regression to fit a complex wavy pattern, it would not be able to learn the important trends. Insufficient feature engineering. Feature engineering is all about transforming and creating new features to help the model learn better. If the data lacks important features or if the features are not helpful, the model might struggle to learn. Irrelevant features. Including too many irrelevant features in the training data can confuse the model and lead to underfitting. In this case, using feature selection technique can help by removing unnecessary information. Let's talk about what happens when a model is underfitting or overfitting. Overfitting results in a model that performs very well on training data but poorly on new data. This means it has learned too much noise and random detail, and it struggles to make accurate prediction on real world tasks. We call this high variance. The model is too sensitive to specific training data. Underfitting leads to poor performance on both training data as well as new data. The model is too simple and misses important patterns. We call the high bias. The model is not learning enough from the data. So how do you know if your model is overfitting or underfitting? Training and validation set performance. You can compare how your model performs on the training set and a separate validation set. If it does really well on training set but poorly on validation set, that is a sign of overfitting. It performs poorly on both that is underfitting. Learning curves. Overfitting can spotted by looking the learning curves. As the training goes on, training error will keep decreasing, but the validation error will start increasing or stay flat. For underfitting, both the training and validation error stay high and the model stops improving early. Cross validation helps the data or model on different portion of the data. If there is a big difference in performance across the different test sets, it suggests overfitting. If the performance is consistently bad, that is underfitting. There are several ways to prevent overfitting. Regularization. Regularization adds a penalty to loss function to stop the model from becoming too complex. L1 and L2 regularization are common techniques that encourage simpler models. Early stopping. During training, we can monitor the model perform on the validation set. If it starts to get worse while the training set performance improves, we stop the training early to prevent overfitting. Data augmentation. Data augmentation increase the size of your training set by creating slightly different version of your existing data. This helps to expose the model to more variation and reduce overfitting. Assemble methods. These methods combine multiple models to make a final prediction. By averaging their result, assemble model reduce variance and improve generalization. To avoid underfitting, there are some techniques you can try. Increase model complexity. Use a more advanced model with more parameters. For example, switching from linear regression to decision tree might help capture more complex pattern. Feature engineering. This involves creating a new feature or transforming existing one to make the data more informative. By adding more meaningful features, the model will have a better chance to learn useful pattern. We have covered earlier feature engineering in this channel. You can watch it. Optimize hyperparameter. Hyperparameter control how your model learns, turning them such as adjusting learning rates or increasing the depth of tree in a decision tree can help the model learn more efficiently. Gather more data. More data helps the model better capture pattern. With more examples, the model can learn the generalize and improve its performance on unseen data. Now, let's talk about challenges of balancing model complexity. Model complexity refers to how flexible and powerful the model is. Bias happens when the model is too simple, leading to underfitting. It is not able to capture the true pattern in the data. Variance happen when the model is too sensitive to training data, leading to overfitting. The goal is to find sweet spot where the model has just the right level of complexity to capture important patterns without overfitting. To summarize, overfitting and underfitting are common problems that can affect how well your machine learning model perform. Overfitting occurs when the model is too complex and learn the noise in the data, while underfitting happens when the model is too simple and misses important patterns. The key is to find a balance where the model is not too simple or not too complex. To do this, you can use techniques like regularization, early stopping, feature engineering, and cross validation. Building good machine learning model takes time and effort, but by continuously evaluating and improving our model, you will get better result. Thank you for watching this video. I hope you find it helpful. If you did, don't forget to like, share and subscribe to the channel. Also hit the bell icon to get notified when I post more videos on data science and machine learning. See you next time. Bye bye. Thank you so much.